Okay, good afternoon, everybody. I'm really glad to be here for, I don't know if it's the fourth or the fifth time that we met together for this appointment, which is namely urban transformation in the world. This appointment should be a little bit more, special than the previous one because we have a guest invited in person, which has been a colleague of us. And we have a long time collaboration, both Oscar and me, with Silvia. Silvia is a professor, assistant professor of urban planning at the Politecnico di Milano. And we have a long piece of living together because we were both part of a laboratory in the Politecnico di Milano where we developed our ecosystem service approach into urban land use planning. Today, she will introduce you briefly a kind of ecosystem service perspective from the city of Milano. This is an advancement that we have recently made because we have used the last version of the updated Invest toolbar, and we use the urban cooling model both and the risk of flooding assessment models. So Silvia will briefly introduce you into the fields of ecosystem service assessment and mapping. I'm happy of this because it's the first time that this kind of important issue will be faced within these kind of occasions, which are simply and brief communication. Silvia has an expertise on these fields of research because also her PhD thesis concerned the utilization of ecosystem service models to assess the kind of impacts that urban land transformation has in the environment. So she's a kind of expertise in assessing how land use change transformation could be balanced through compensation or mitigation measures. Well, today she will get into the touch of these new urban models, so I will be quite happy to announce you that she will be ready to present also because we have some publications in these fields. She will talk later on about that. And so you can go in depth and search for other kind of materials around this kind of issue. Well, I don't want to take much more time than needed, so I would like to leave the floor to Silvia and to leave her to explain the matters concerning this appointment. Thank you, Silvia.
Thank you. Good morning to everyone. So thank you, Oscar and Stefano, for inviting me to present this research that concerns an application that we conduct in the city of Milan on urban ecosystem service mapping for planning purposes. This studies was elaborated 1 year ago together with Stefano and also with Professor Arcidiacono. And at the end of my presentation, I leave you the link for download the paper with this research that was published in the journal Sustainable Citizen Society. So if you want to go deep in the details, you have the link and you can download the paper with all the information necessary. So before starting, before going deep with the research, I would like to start with some first assumptions that are necessary to set the framework of the research. The first one is that we consider the forecasted increase elaborated by the United Nations on the world's population that lives in urban area, which will pass from 55% to 68% by 2050 in all the world. In Europe, this percentage is higher, is around 72%, and only 39% of the people lives in areas, in cities, that at least 50,000 inhabitants. So this causes a rapid urban expansion with the impact on the natural capital. Natural capital means the world stock of natural resources, which include, for example, soil, air, water, geology, and all the living organisms that provides important benefits to human well-being. So this rapid expansion is strictly connected also with the effect of the global warming. So the different changes depending on the climate condition. that cause an intensification in terms of number of extreme events and also the intensity of these events. For example, heat waves and flooding, that makes our territories and especially cities and urban areas more fragile than the past, and so more exposed to disaster risk. The last aspect that we consider inside our research concerns the urban morphology. So such morphological parameter shape cities, as for example, the urban density, the built form, the different infrastructural system, the building orientation, and all of these aspects could influence the absorption of solar radiation and so increase the temperature, so the level of the temperature differently from the natural landscape. So all of these three elements, so the forecasted increase of world population, the effect of global warming, plus the urban morphologies, have a fourth impact, so have worse, the urban Italian effect, which have different impacts on citizen health, leading to respiratory and also cardiovascular problems. Urban in Thailand could be defined as the microclimate events that occur especially in cities and urban areas, causing an increase of the level of temperature compared by the surrounding area, for example, the natural or the rural one. This effect depends on the combination, the coexistence of multiple aspects. For example, the energy consumption for the conditionings of building, for heating, but also for cooling. The air pollution that is strictly linked with the road traffic, as well as the increase of imperviousness, so the impermeable surfaces, the soil sealing process that cause degradation of permeable and green areas. So urban Thailand is nowadays one of the major challenges for planning, because with different urban design parameters, we can increase the performance of the cities for mitigating this kind of effects, so the urban Thailand. For example, ensuring the permeability of the area, creating more vegetated land, or maybe use such kind of materials that could decrease the level of the temperature inside cities. One possible option for planning is to use the nature-based solution. NBS, this is the acronym, are different solutions, different from the traditional one, because they are inspired and supported by the use of natural process. The elements, the key elements of nature-based solution is to provide multiple benefits, not only in terms of natural or environmental one, but also from the economic and social. So nature-based solutions are a key components for planners to create cities that are more able to provide ecosystem services. Ecosystem services, and especially the evaluation of cooling capacity, could allow us, and also planner, to identify the most suitable use of land and setting precise urban design parameters for increase the quality of citizen life, and also for have a climate-proof planning, so a climate-proof cities. After this first assumption, I would like to present in details our research, starting from the research aims. So inside this work, we want to try to think about the contribution of urban green areas. And we did it considering one of the most urbanized areas, that is the city of Milan. We want to see the contribution of urban green areas for mitigating and reducing the urban Thailand. The second aim is to verify if there are some historical periods that are connected with what we call urban planning season, and after I can explain better what I intend with these terms. We want to see if there are some historical periods that are more familiar with the use of such criteria that have contributed to the microclimate regulation, so to mitigating the urban heat island. The last aspect concerns the question that we would like to see what are or what is the major morphological parameter that can contribute for the urban comfort, so mitigating the high level of temperature in urban areas. To do that, so a couple of words concerning our case studies. So as I said, we are in the city of Milan. So in Italy, Lombardy region, we are the northeastern part of the Lombardy region. The city of Milan is situated more or less at the core of an extensive socio-economic and settlement system that is called Milan metropolitan areas, and is located in the upper plain of the Po River. It's characterized by the humid and subtropical climate with cold winters and hot summers, and also with different thunderstorm events. The city is the second most densely populated in Italy. The first one is Naples, with more or less 7,600 inhabitants per square meters. The temperature is quite varied, from -2 degrees in January until more than 24 registered in July. Despite that, so you can see that we are in a dense urban area. We have also a lot of important urban green parks located inside the anthropic land use. And the city is surrounded by a South Agricultural Park that goes from east to west of the city. I don't know if you can see my mouse. This is the extension of the South Milan Agricultural Park.
Yes, we can see, Silvia.
Perfect. So, concerning the method that we use for doing this research, two important aspects. The first one is the mapping and assessment of urban cooling capacity. We use Invest, that is a software provided by the Natural Capital Project and elaborated by the University of Stanford, the University of Minnesota, the Nature Conservancy, and also the WWF. The model, this kind of model, so urban cooling capacity, is quite recent and requires different output. So the first one is quite common when you have to use Invest, and is the land use land cover. And it's better that is the very detailed land use land cover, because this influences strictly the outputs of the model. The second package of information concerns the urban green spaces in terms of quantity, extension, the quality, the shading, the vegetation density, and also the bed information. The third package of information concerns the climatic condition in terms of evapotranspiration and the atmospheric temperature, means the maximum, minimum, and also the mean of temperature in a period that you have to set. The second aspect concerning the method is a morphological analysis. So we select 13 urban districts that correspond to 4 different historical planning periods that you have listed in the slide. What are the historical planning periods and why we select these different urban districts? The historical planning period are some area of the city of Milano that we can reconnect to a traditional planning system. The first one is the city that was built during the 19th century and was connected with the Piano Beruto's plan. And the characters of this kind of scheme is characterized by a regular grid with an homogeneous distribution of green spaces, green areas, so streets, square, public spaces, all around the cities, with a very balanced distribution of green spaces. Two important elements of this kind of approach are the boulevard, the green boulevard with 3 lines. The modern cities correspond with the early 20th century and was developed after the war on the basis of the rationalist principle of the modern movement. So there are different new expansion areas included in this plan, located both in the east and the west part of the city. The third historical periods concern the 60th and 70th century and include all the urban expansion that were decided during the period of the economic boom, so a strong demographic growth. And this kind of plan create a numerous suburban urban districts that are more or less independent from the city center and characterized by a monofunctional destination. The last one is the contemporary city, that is the city that was built in the last 30 years, and include the requalification and the redevelopment of different large industrial areas. Large industrial areas that are very, very close to the city center. And they were rebuilt with new function, new destination, mainly a combination of different function, residential, but also commercial and tertiary. All of these 13 urban districts that we consider for this analysis, where we developed different urban design parameters that are listed also in the slides. So we provide for each of these urban districts the territorial surface, the permeability ratio, the build-up footprint, the territorial equalization index, that is the building volume divided by the territorial surface of the urban district, the average height of buildings, the tree densities, the average of tree, and also the average dimension of the tree areas. These are the 13 urban districts that were selected for our morphological analysis. You can see with different color their connection with the historical planning season, the historical planning system. And we arrive at the result. We have the first result, that is an overlapping of the average cooling capacity that was developed using INVEST with the different 13 urban districts of Milan divided into historical planning periods. So what we can see from these first maps, that okay, despite the results could be seems quite intuitive, because we have in red the area that have less cooling capacity, and in blue that correspond mainly on the agricultural park in the peri-urban areas of the city, are in blue, so a good quality in the provision of cooling capacity. But despite that, we can also consider that we have a different degree of extension and intensity of the mitigation effect, and this could be quite interesting, because we can denote how different urban green areas can significantly reduce the urban heat island, even if in areas that are not strictly related and contiguous to urban green spaces. This is the case, for example, if you see my mouse, of the North Milan Park that is located here, but the influence of its cooling capacity arrive in areas that are quite dense and very, very close also to the city center, that is quite is one of the most compact area of the north of Milan. So this is interesting for understand the extension of this phenomenon, and try to see also how the different open spaces could have an effect and could reflect its benefit also in very compact city. This is a table, but I don't want to spend so much time, because I know that is quite not easy to understand immediate, but these are the results from the morphological analysis. So all the data deriving from the urban design parameter that were calculated for each different urban districts. But a scheme that is quite clear is that, and concern the average cooling capacity, so the distribution of the average cooling capacity on each urban different district. And we can see that there is a growing trend on the mean, so the average cooling capacity value among different districts. And what are these districts? Are mainly three. and they are not from the same urban planning season. So the 3 urban districts with the greatest cooling capacity are from different urban planning season. So we can say that apparently there is not a period of construction that could provide a better ecosystem services capacity in terms of cooling than the others. But if we can analyze in details all of these results, we can see that there is a growing trend is quite visible with a rate of major 1+37 during the last periodization, so during the contemporary city and the city of 16 and 17. And we can observe after a decrease of the average cooling capacity. This can be, we want to answer. So if we see this increase, we want to know, okay, I can see this increase in the average cooling capacity, but what are the urban planning parameters that can influence and have a greatest impact on the supply of the cooling capacity? So what are the parameters that a planner can consider when he have to make an urban plan? So we split all of these results considering the different 13 urban design districts, and we can see the different planning parameters. So inside this chart, you have the 8, so from the 2 until the 8 parameters. The first one was the territorial surfaces, so was not considered for this analysis. And we can see the different distribution of this urban design parameter to see what are the most important parameters to be considered for mitigating the urban climate effect. So the first one is that the permeability, that was one of the most debated urban design parameters during the last century, especially in Italy, is not so influenced, is not a sufficient condition for reaching a higher cooling capacity. That is differently from, for example, the compact green spaces. So if you have a compact green spaces well connected with other green spaces without any kind of fragmentation, and also with a dimension that is major of 2 hectares, you can have a very high increase of the cooling capacity of a district. So this dynamic, for example, you can see in one of the different urban design parameters, so the 3B, this one, where you have a high percentage of permeable surfaces, but less average of green areas. So the capacity of these districts could not be so high because the average dimension of green areas are quite small and also very fragmented, different from other districts, for example, that has a compact green spaces quite large that could provide a major effect, a major benefits. Another results is quite interesting that the last part of the cities built during the 30 years, the last 30 years, so the contemporary cities, has not delivered the highest average cooling capacity. So this finding can be explained maybe by 2 important facts. The first one is that the contemporary buildings, so the new buildings, are averagely higher than the old part, but the height is also associated with higher build-up footprint and territorial utilization index. So mean that the ground footprint is quite higher and have an effect on the cooling capacity. So the ground footprint impact on the tallest building is higher. Secondly, the tree density is quite important. And you know that a new district mainly has a very young planted trees that can provide a capacity in terms of canopy cover because the plants, the trees are quite young. So the effect of the cooling capacity is quite influenced by not the number of the trees that are planted, but on the species and their respective canopy cover that can influence mainly the provision of cooling capacity. I arrived just on the conclusion, so such important things that I want to remark, I also already explained during my presentation, but I want to highlight better, is that this study conducts an empirical research investigating the relationship between the average cooling capacity and the urban design parameter for certain districts selected in the city of Milan. Make evidence what? That the territorial utilization index that usually was used to define the estimation, the impact of urban transformation, especially in Italy, is not a key data, key elements in defining a climate-proof cities, differently from the footprint and the distribution of the gross floor area. They are much more relevant, and we also see during my last example. Another important issues concern the design of green areas that need to be compact, firstly, not fragmented and well connected with other green areas close to this one. And also the size of the area is quite important. So we have to design compact green area and also large green areas that are more than 2 hectares. Mainly this is the size. Another important aspect to be considered is not the selection of the number of trees, as sometimes we see in different projects, the number of trees that we have to plant, but it's better to select the species in terms of the high shadowing capacity that this kind of species could provide in order to mitigate the possible increase of temperature. The last one is that these studies is in line with a new development form of things that are more familiar with what we call performance-based planning. So a changing in the urban planning paradigm that is not more related on land use management, but is more propense to use the ecosystem services to provide a quality of the land for the provision of new benefits for human well-being. So this is in line with this kind of approach. So using ecosystem services, and in this case, the cooling capacity to set the best urban design parameter for having a climate-proof cities. And in order to have a territory that is more less fragile and more resilient for the new risk also deriving from the global warming. So this is my presentation, and I just arrived from the link. This is the link of our publication that we made. You can download easily from the website of the journal Sustainable Cities and Society, but I also think that if you want the publication, you can't download it. You can write me an email on to Stefano to have the publication with all the details of this research that I explain in a very brief presentation. Thank you, and all your welcome, all your questions are very, very welcome.
Thank you, Silvia. Thank you very much for your super presentation. I don't have anything to add because you were so complete in your presentation. So I think that the slides were quite, you know, full of elements that give to the followers the possibility to have certain kind of, you know, issues. And if they want to make, for example, questions, they are welcomed, of course. What I want to stress is the fact that we are using ecosystem service within the lens of urban planners, not the lens of the environmental scientists and so on. I would like to stress this fact because as urban planners, we have the need to use empirical research on ecosystem service as you have been done and presented, because we can understand the link between cause-effect mechanism of how we want to build up and transform the space and the effects on ecosystems. If we are not able to understand empirically these kind of assumptions, we are not able to control at all, I mean, the effect that our urban transformation has in the climate change, for example, because as you told, the assumption is that the climate is changing and is changing so fastly in the urban regions because of the density of urban population. So the population, especially elderly and child, are suffering as much of this kind of changing situation. So in the end, I think that these kind of models are quite helpful in order to have a first preliminary assessment of that, because we are well aware of the fact that using modeling have some limitations. For example, Invest especially has a huge amount of inputs, but we are not able to control at all, I mean, the possibility to understand if this kind of variation in the cooling capacity is realistically or just an empirical assessment that we can use in order to make on-site measurement. I think this is an important problem, because in the next future we have to test and evaluate if this kind of modeling session are really helpful and also quite readable in order to set urban design parameters. In the end, I think that this first preliminary research was so important, because we have, you know, this kind of not banal first evaluations. For example, considering what Sylvia has previously told, that, for example, permeability is not enough to reach a good cooling capacity. If you have the same permeable areas, the ones that achieve a more cooling capacity is the one that is more connected and more dense of green, instead of one which could be more fragmented. And this is a typical example of the contemporary urban transformation that's used to make permeable space much more fragmented than during the, for example, modern movement, when for example, urban transformation tried to emphasize the parts where the building should be built up using vertical space, and the other parts that should be remained permeable, sorry, and with a huge plantation of trees. So thank you again. At least I don't see that anyone raised his hands to make questions, but if you want, you can switch up the microphone and we can interact. I have to state that Oscar will help us in coping this, is making you know, not an online registration of this course and discussion. So in the next days you will find that in our channel, in our Facebook channel, we will have the possibility to upload this communication made by Sylvia. So if someone of you will be interested in following the course, you can do it also remotely by your PCs whenever you prefer, when you have got your free time. At least I would like to encourage you, as I always do when we make the final statements of this communication, that you are the main actors of this situation. So I would like to invite you also to ask if you want to make a speech for the next and incoming events. We are planning some important events in the next future, and we are trying to go ahead within the presentation made by researchers, Sylvia, me, Oscar, and others. I thank you again within the previous presenters, and if they want to reply with another advancements of their work, they are also welcome. So again, thank you very much. We are still not too much as expected, but we are growing, and I hope that the trend will be growing also in the next future. So please use also your channels such as Facebook, ResearchGate, Twitter, or what else to augment the number of interactions that we have got. Our I mean, research is made on Facebook, on Gmail, with our communication by Gmail. We have the Facebook, we have ResearchGate, you know, so we have many platforms where we can share our initiative. So just these kind of final endings. Thank you again for having followed us, and see you later on in our next webinar meetings. Thank you very much. Thank you, Sylvia, again. Thank you, Oscar.
Thank you, Stefano. Thank you, Oscar.
Bye.
See you soon.
Bye-bye.